The controversy. Really, Jeff? All right, give me a second. Let's go find 931. Let's just see it up. Ooh. Make it make it 951. So obviously this is actual rate. Test the claim at the take a sample and find it. Oh, I see. They were sharing. It was like a, what is it, covalent bond? They were sharing this with me. Is that the right one? No, it's got the wrong one. Ionic. Some kind of bond where they share the screw. Covalent? It is covalent?
Yeah, covalent.
I got it right. Sorry. Test the claim at the 0.01 level of significance. All right. So this is not a word problem, but just like a word problem in algebra, your first thing that you're interested in is not mathematical, really. It's just what was the claim that was made. So a claim was made.
Would it be P?
Yeah, so the claim is P.
Greater than or equal to
Yeah.
0.75.
0.75, I like it. So which one is that going to be? The hope. And so what's the H1? What's the high going to be? All right, let's see if you guys can handle this. You realize I did just make this whole thing up right now? So if you can't handle it too damn bad, make this, this actually makes sense. Just make it 921. Let's see what happens. I don't.
What'd you change?
Make that one 921. How many tail tests is it going to be? One tail test. And the tail's going to be where? It's going to be down, right? It's not the claim. The claim doesn't set it up. The claim gets me started and then I forget about it. What always sets that up is H1. H1 is the one that thinks it's a string. HO is the one that thinks it's in the middle somewhere, so it's never going to set up the evidence to show it's not in the middle. Well, after I set these up, if that's the only way that this would be two tails, if this was not equal to. Before I set this up, there is a directional word in here, right? It feels at least, which means there's a direction I want to show evidence for. Okay. How do I check to see if I can use z-scores? Yep, n times p, n times q. N was 1252. What's p? 0.75. So q, of course, will be 0.25. Yeah, 939. 313, yep, cool. And of course, those are both bigger than 5. Check. That check actually tells me what? Normal enough. I love it. And now I set up what's going to be enough evidence. So I know it's a one-tail, so we can use z-scores. I know it's a one-tail test. I know alpha is 0.01. One tail, 0.01 z-score.
That's 2.326.
Cool. So it's going to be negative 2.326. So if z star is less than negative 2.326, reject. Oh, support high.
Wait. How do you get the z-score again? You look at 0.01.
T-chart.
Oh, the T-chart, okay.
Yes, T-chart makes it so much easier. T-chart is set up for hypothesis tests, and we remember that z-scores live at the bottom, so we're okay with finding z-scores on the t-score. So now I've got set up what enough evidence is going to be. Then I go see how far I got. So what do I know from the sampling? How do I get p hat? Yeah, so it's 921 over 1252.
0.74.
0.7. 740?
7.356.
0.736?
356.
All right. At least 3 places on those. Right? And remember what I said before. If you just round everything to 4 places, you're fine. Because I said at least 3 for standard deviation, at least 3 for p. We use 4 for percentages. If you make everything 4, you're beautiful. Right? Oh, you're beautiful. Now I got everything I need. Believe it or not, z star equals p hat minus p over the square root of pq over n. Notice how these don't have hats on them, right? P hat was 0.736. That's my data minus the thing I see in the claim divided by square root 0.75 times 0.25 divided by 1252. Screw it. I'm not going to do that in my head. Stop trying, Jeff. Yes.
45.1.
Whoa. Is it really? Maybe.
Negative 1.14.
It sounds more like what I expected, but.
Oh, I just don't mind.
Okay. So what are you going to start? Negative 1.14?
1.14. Yeah.
Is that what you guys got? Everybody? Oh yeah, people shaking their head, yeah, they don't even have a calculator out. I like. What's the p-value then? So we got to about right here, right? So what's the p-value?
1.1271.
Who is it, sorry?
1.1271.
1271, so you just look that up. 1271. If it was positive, you have to do 1 minus, so you actually get up in the tail there. So right here, what do I know? Even from just this, what do I know? Did we make it far enough? No, so we fail to reject. Fail to support the high. And now which one was my claim? My claim was the hoe. So I'm going to use that language. So what does fail become? Fail becomes we have not found sufficient evidence to reject the claim that at least 75% of people want to see blah, blah, blah. You just copy it from there. Please do not. Don't make me write more. Are we, if we're the people that made the claim, are we happy about the outcome? Yeah, because we didn't find evidence to reject our claim. Our claim was the hoe. We didn't find evidence to reject it. We're happy.
Doing the one bar stats, when you put it all in, like just for L1, is it all for population, or is there like population and sample? Like
the only thing, I mean, X bars, even if it's a population, it still just means the mean. But you have to know, is it a sample you put in and you take S? Is it a population you put in and you use sigma? It's going to tell you both because it doesn't know.
Okay. For 7, how do you know that it's in normal distribution?
Oh, okay. We don't know. The question is, why must we assume this is normal? What part of the process could I not do if it wasn't normal? Exactly what part? So what is the process? How would you find probabilities? What would you do? Like to do part B, what would you have to do? You have to take that 6.2 and make it into a z-score and then look that up in the z-score chart. Which step in that process could I not do if it wasn't normal? What only works if I know it's a normal distribution? Z-score chart, exactly. I can always calculate z-scores. I can always do that. But the z-score chart is specifically for normal distribution. So why must we assume this is normal before calculating probabilities? Because the answers, the probabilities are in the z-score chart. We can only use that if it's normal.
So the answer is that it's in the z-score chart?
Because we can't use the z-score chart unless it is normal enough. Yeah. So this is kind of a different problem here. There's no reason to believe it is normal, but I just say, assuming it's normal, do this, right? Now, in the real world, there could be reasons why you would assume it's normal. You can make a histogram, and it goes up, and it comes down, and you're like, that looks like it's probably normal. I mean, right? So there are reasons why you could assume it's normal, but why do you even want to be able to do that so I can use a z-score chart? That's all. So on the second part, if I take a sample of 38 students, do we still need to assume that it's normal? No, we don't, because it's greater than 30. Central limit theorem says it's normal enough. I don't have to assume anything. Cool. I like it. Yeah.
On top of that, on 7B, we would use X bar over minus mu over standard deviation.
For 7, first part B, you would do X bar minus, or X minus mu over sigma. Right? And then for the second part, you would use X minus mu over sigma X bar. You have to change, right? That's the whole point of the second part. You have to change the standard deviation. All right. Type 1 error. And it's really just two errors you could make. Because there's only two things I could end up. I could either reject the null, support that, or I can fail to do this. Right? So there's only two things I could do. So what if the null, whatever the null is, what if the null actually is true? How could I make a mistake? At the end of my hypothesis test, I end up rejecting it. I really want this to make sense. If the null is actually true, the null, whatever that is actually true, when would it be a mistake if at the end I reject it? Do I have any idea that I made a mistake? None. In the real world, I don't know what the real mean or the real percentage is. So I don't even know I made a mistake. I just know the probability I made a mistake. But what are those mistakes? The type 1 error is to reject a true null. So what if the null was false? Then what would a mistake be? To fail to reject it if it's false. If it's false, I need to reject it. But it's not like a mistake on our part. It's not like our mistake. We didn't make a mistake in the work or anything. It's just a mistake we would never know was made. Which is why people don't believe in statistics. But it's the most honest. I love it. They're saying, all right, do shit based on this, but there's a chance it's wrong. Yeah.
So it has nothing to do with the evidence that you got?
It has nothing to do with your work. It's not a mistake in your work. It's just what could I have gotten wrong, even if I did all the work right. There's always a chance something went wrong. There's always that 5%, 1% chance. Right? So I could have said, I could have rejected the null, but it actually, in reality, the null was true. There's just no way to know that. We can just collect evidence. So this is sort of like saying somebody's guilty when in reality they were innocent. We found evidence that they were guilty when in reality they were innocent. Do you guys? So a lot of times hypothesis tests are thought of as the same thing as like a court case, right? So trying to collect evidence to show something. So what mistake can you make? You can send somebody to jail when actually they're innocent, right? Or I could fail to reject a false null. So for a specific example, on this last one, what was the null was, let's see if I remember. I think that was this and this was this, right? That was the one with my grades, I think, right? Or no, that's the one with the... Yeah, the Trump tax return stuff. So a type 1 error would be, we find evidence that it's not at least 75%, when in reality, it is at least 75%. That's it. So reject a true null. So it actually is at least 75%, but we found evidence that it isn't. So what would a type 2 error be? It actually isn't at least 75%, but we found evidence that it is. Right? And we failed to reject it, even though it actually was false. Yes? There's a non-mathematical example I'd like to give. Like you're a medic in a battlefield. Right? Or you're playing some stupid freaking online game, and you're the medic. And you're out there in the battlefield, there's people laying around, right? When you come up to a person, what are you checking to see? Check to see if they're dead or alive, right? So it depends on you, but what do you want to call the null, and what do you want to call the alternate?
Dead and alive.
Okay, go. So I could say the null is that they're dead, and the alternate is that they're alive. I'm trying to gather evidence that they're alive. So I come up to a person and I think, and I make a type 1 error, which means what? In actuality, what's true about this person?
They're actually alive.
All right, let's see. Type 1 error is the null is true, right? The mistake I make is that I reject a true null. So if I'm talking about a type 1 error, what is true? They are actually dead. But I think that they are alive. I reject this. So how do I do that? Well, I'm not a very good medic, and I feel my own thumb pulse instead of feeling the pulse correctly, right? I'm like, oh my God. Or you go check for breath, and the wind comes. Oh my God, the breathing. All right, now, how bad is that? That's bad because why is that bad? Because wasting time. Right? So what about a type 2 error? The null is false, so they are actually alive, but I failed to reject it, so I think that they are dead. Oh, that would so desperately suck, right? I'm like, oh, thank God the medic. Oh, wait. Oh, shit. I'm like, please come back and help me. Right?
How would we write that answer? No, it would just be us writing.
Well, that's exactly what we just said. So type 1 would be, they're actually dead, but we think they're alive.
So
You can say exactly that.
Written response.
Yes, that's it. That's what a type 1 error is. Type 2 is, they are not dead, but we think they are dead. And that would be a mistake, right? Sometimes it helps to step away from the math for a second, just get, so this works for non-mathematical hypotheses too. The same kind of errors can be made. Okay. Like that. You ever seen Poltergeist 2 or that weird dude whistling down the street? How you? All right, so anything else we need to cover? This goes from the kind of problem that throws people off, that should be your bread and butter, is number 7. That's your classic z-score problem, and then you change the standard deviation and do all the same work. But people just get thrown off about that for some reason. Probably because there's a lot of stuff you got to remember all. Let's see, what else have we not really covered? Oh, let me give you the answer. That's probably good. What about? Oh, well, the back was when we did in class. Yeah. So it's up on the video. I like how you're looking at me expectantly. I have nothing. It's based on what you got. Show me what you got. You can go. Don't worry. I won't take your name down or something. Just appreciate that you're here. College, you didn't even have to be here in the first place. Exactly. So you should be here, right? Yeah, but not everybody looks at that. Test day, I get to see everybody. It's great. Aw, I almost remember some of you.
What about for easy problems? Would you still recommend using or find that to be a better or would you just tell somebody to go to the business? Or can we go to 1tail.01?
Yeah, of course. That'll work.
That would probably be more truly answer, right?
Well, it does go out one more decimal place, but that's not as important as maybe it's just easier to use a t-score chart. Now, if I ask you you make like a 97% confidence interval, the T-score chart won't help you.
Yeah.
It doesn't have that many entries, and you have to do it the old-fashioned way. Look it up. Oh, so did you already put it in? Oh, hit second click. Now hit stat. Edit. Edit. And so it's in there? No, that's old stuff, right? So you would just put like all this stuff you would put here. Then you hit stat. Count one of our stats. If you did, and if you have your data in L1, mean, deviation.
No, I have questions on that too. Are you sure? Because I put so confused.
Okay.
I don't remember it died. Maybe something went down.
Samples.
I don't even know what question.
Look, these are samples, right? So then I'm going to use that. It's giving me both because the calculator doesn't know.
Okay.
Yeah. We as the humans have to decide.
So
Yeah.
when the day is done, finish your steps again?
Let me in the data.
Enter all this, you can have to-
Yep, sure. And if you put it in L2, when you go to stats, count one of our stats, you'll tell it L2 after you put the data in. You can change it to a different list, yeah. Yeah. Yeah, yeah. Sure.
Asking for the confidence interval for each